Okay, so we learned that in order to compute confidence interval, first we have to calculate the standard error by the formula standard error is equal to standard deviation over square root of n. And then the second step, we determine the 95% confidence interval bounds, lower confidence interval being the mean of the sample minus two standard errors, and the upper confidence interval bound of 95% would be the mean of the sample plus two standard errors. Now, if you notice in the formula, this under root of a standard deviation divided by under root square root n. Okay, so as the sample size increase, as you can imagine, the standard errors will become smaller and smaller. And in the second step, you will see that the confidence interval bounds will become tighter and tighter. Let me show you on the Excel sheet. Okay, so to calculate the standard error over here, we use a sample of around 100 individuals, right? So when we calculated the standard errors, that the full sample that we used for our calculation over here, the standard error, and if you look at the formula, standard deviation, um, that is of the first sample, the D2 cell to CY2, divided by square root of 100. And we see that our confidence interval is very nice. Sorry about that. Very nicely between 84 millimeters of mercury and almost 90 millimeters of mercury. So that's a range of something like around 6 millimeters of mercury or less. Okay, because again, the formula for the standard errors includes division by the square root of the size of the sample. But what if we have a sample of, say, 50? Now we see that the confidence interval bounds are becoming larger. In this case, now the difference instead of 6 is almost 7 or more. And if we have even smaller sample, something like, say, only 10 individuals, now our confidence interval bounds are going really crazy. Lower bound being 76 and upper bound 93. That's a difference of almost 14 millimeters of mercury. That's very wide confidence interval. The problem would be that when we will be calculating the difference between the different levels of exposure for the continuous outcome, the confidence interval becomes so wide that it will invariably be containing zero, meaning that we will not get the statistical significance very easily with a very small sample. And conversely, if we have a very large sample, say we have a sample of, say, 1,000 individuals, in that case it should be very tight, and we can see that it is only 1 millimeter or 1.5 millimeter of mercury range in which we are estimating the actual population means. So in a nutshell, the larger the sample we will have, more precise our estimates would be about the true population means.